Hello! I recently travelled to New Zealand to visit the Aeronautical Engineer in the family. I was able to visit his R&D Workshop and pick up some hints and tips on lightweight construction of foam RC planes. On a previous visit, I had provided him with some A4 sheets of 3mm printing foam. I was keen to see what he'd made from it. During the visit, the weather was perfect, so we were even able to test fly some of his planes. It was a very quiet road outside his house, so we were able to take off and land the smaller planes on the road. For the larger one, we took off from the house, then wandered down to the waterfront, which is only a few metres away from his house. Very convenient. This little plane's wings had been made from printing foam. It's had 3 slits made across the top and then glued up with PVA with a little thin strip of tissue. It's also had the leading edge and trailing edge sanded slightly to give a nice aerofoil shape. This little plane has a 570mm wingspan, flying weight of 44 grams, and is powered by a 1S 300mAh cell. The motor is a 716 brushless and a direct drive 49mm prop. The fuselage is 3D printed, and note the use of cotton for the VTOL controls. In the quiet suburbs of Auckland, we were able to test fly it from the front driveway.
Let it rocket up.
This little plane is suitable for those windless days and would be great indoors.
But I might land where you are.
Safely down. This next one has a 700mm wingspan and a flying weight of about 100 grams. It runs 1S with a brushless motor and a 152mm propeller.
Here she comes, landing on the street, skimming the car. Nicely done.
Finally, we flew this 1100mm wingspan plane, which comes in at 400 grams, runs 2S, and is powered by a brushless motor driving a 230mm direct drive prop. We took off from home, then wandered down to the waterfront to do some touch and goes.
Trim's a bit out. And it's still too fast and too high.
This plane has 3-axis control with ailerons. Good landing. The battery died, necessitating an emergency landing. Well, that passerby was impressed. Let's try that again with a new battery. That background chirping noise that you can hear is the New Zealand cicada. It's a little bit quieter than the Australian cicada, which is more akin to a hydraulic ram. Here I egged the pilot on to give it some willy and do some aerobatics, and down the track there were consequences, as you will see.
Oh, not terribly good.
Yeah. Whoa.
There's enough aileron there to roll.
Yeah. High speed run.
I think we're starting to lose a bit of power. Oh, look! Oh no!
Oh, it lost control.
Yeah.
Crash investigation revealed that the JST connector and the wires around it melted, probably caused by the pilot being egged on to flog it along. I believe this will be replaced with an XT30 connector in the future. His use of printing foam was not limited to just wings. Using this to build what would classically be a balsa fuselage, he was able to create a much lighter but still strong fuselage from this material. Here are some pictures from the construction process using printing foam. This one ended up with a 680mm wingspan and a flying weight of 105 grams. It's powered by a 300mAh LiPo, and I've been told it flies like a charm. He's really into improving the efficiency of his propellers. In this box there's some examples made before and after the 3D printer. The ones made with the 3D printer are done in 2 halves and then glued together. He's made 20 more since this photograph was taken. Here's an example of a 3D printed propeller and gearbox, and here's a comparison with the store-bought gearbox. These gearboxes were made for brushless motors. And one last thing, his experience with motors, batteries and 3D printing has not been limited to RC planes. He also had a manicured lawn which was clipped to perfection by Mark I and Mark II reel mowers, which have been modified to have DC motors powering the rotary reel blades, making the task of mowing the lawn a breeze. How about that? During my visit, I was able to pick up quite a few hints and tips on construction using basic materials and a lot of ingenuity. It also helps to have CAD skills and a 3D printer, of course. I hope you enjoyed this insight into the source of a lot of my building knowledge. And as always, if you would like to stay tuned to my progress through my projects, subscribe to DavesFunRC and I'll see you in the next one. Bye for now.